Hey, this is Justin with Lesser Dog Tutorials, and this is the Retro FPS tutorial series for Unreal 5. And this is episode 6, in which we focus on health and armor. And so before we get into the actual project itself, make sure it's closed because we're going to do a little more C++. It's not going to be that complicated. All we're going to want to do is say how the logic is going to work if one of our characters receives damage and they have armor and also health, because we want to take away armor first and then take away health. Or if they have no armor, we want to only take away health. So if you were to look at the official documentation for the gameplay attributes and gameplay effects at unrealengine.com, you can kind of see some stuff about the attributes, about the effects, but if you scroll all the way down, you'll see this programming effect and attribute interaction. And this is basically several functions that an attribute set can override to deal with the way that an attribute responds when a gameplay effect attempts to modify it. So we have these things like pre-attribute change and pre-attribute base change, which are called right before there's a modification to an attribute. So if there's a modification to the current attribute, that's pre-attribute change. If there's one that modifies the base value, that's pre-attribute base change. Then we have pre-gameplay effect execute, which happens just before modifying an attribute's value. And then we have a post-gameplay effect, which is after the attribute value has been modified. So what we want to do is utilize these, or a couple of them, to try to decide how armor is going to be affected in regards to damage. So what we're going to do is open up this SLN file and not the actual project. Make sure the project is closed and then double click the SLN and we'll open that up in Visual Studio. So once it has loaded and the 3 years that takes for the color syntax to kick in has passed, we're going to make sure that we open the attribute set header file and the attribute set CPP file. So the first thing we'll want to do is add an include up here. And right under the ability system component header, we're just going to include gameplay effect extension. And make sure that's .h, it's the header file for that. And once that header file is in there, we're going to just override a couple of those functions we saw earlier. So we'll want to say virtual void pre-attribute change, and then override with a semicolon, and then a virtual bool, this one's going to be a bool, pre-gameplay effect execute. And that also will be an override with a semicolon. Now, in order to override these, we need to pass in the same variables that they have. And it's actually very easy to find out what those are. You just need to search Unreal Engine's docs, and you can see, for instance, the pre-attribute change. You can even see it's a void, and it has a constant F gameplay attribute called attribute, and a float called new value. And you could just copy this, head back over to C++, just paste it in there, and make sure that it's all on one line. And so that one's done, and we could check the pre-gameplay effect execute, which is right here. You'll see that it's just a struct called F gameplay effect mod callback data called data. And here you can also see that it is a bool, and that's how I figured out that this is a bool. So we'll just paste that back in here. And now we have the variables that we need, and we'll just wait for the color syntax again to kick in. So that might take a while. Now that the syntax is kicked in, you'll see there are green underlines for these. So if you just right-click them and you go to Quick Actions and Refactorings, you can create a definition in the CPP file, which is what we want to do. And then it'll show a kind of little window of the CPP file, but we can close that. And then for the next one, we do the same thing, quick actions and refactorings, create the definition. Once those have been created, the green lines go away, and we can save and head over to the CPP to fill out these functions. In the pre-attribute change section, all we're doing is clamping the new value between 0 and 100. So just make sure it looks like this. And for the pre-gameplay effect execute, I'm only doing a couple things. First thing is I'm declaring a temporary variable that is a float called armor damage, and it's just the magnitude of the evaluated data. So if it was a gameplay effect with -10 to armor, I'm just getting the absolute value of that, which would be +10. So now that we have the armor damage stored, we're just going to use that a couple of times. And essentially what we're doing is we're just checking to see if the amount of damage being given to the character exceeds the character's armor value, because then we want to do the calculation for damaging the player's health as well. Otherwise, we just return true, we just move on. So if it's 10 damage, 10 armor damage, and the character has 20 armor, then we don't need to do this calculation. It's never going to touch his health. It's just going to remove 10 of his armor until he has 10 armor left, and then we just return true and move on. However, if the armor damage is 20 and the character has 10 armor, that means we need to figure out how to remove 10 from the armor, so it's 0, and then remove the remainder, which is another 10 from their health. So all we're doing is checking if the data, we're using this variable here, .evaluated data, .attribute, the attribute being affected by the gameplay effect, is equal to armor, so get armor attribute. And the get armor attribute, that works for any of these gameplay attribute data that you create. So if you made one called strength, then get strength attribute would also work. And this is because of these macros up here. So if the attribute is equal to armor and the armor damage is greater than get armor, meaning if the armor damage coming in exceeds the amount of armor the player has, that's another thing that we want to make sure is true before we affect health, and the evaluated data.magnitude is less than 0, which means it's an attack, it's damage. If it was positive, that would mean that we're gaining armor or gaining health, and we don't want that to be the case. We want it to be negative. So if all of those are true, that means we're going to set the current health value, so health.setCurrentValue, equal to the current value of health minus the armor damage minus get armor. So essentially, if the armor damage is 10 and get armor returns maybe 5, the character has 5 armor, then we're going to do 10 minus 5, which is 5, and then we're subtracting 5 from the current health. And then we return true, and we've done the calculations. So with those done, we're going to go ahead and hit this local Windows debugger and get the game playing. Just make sure you save it first. Now let's test it out. Now that Unreal has loaded and there's no errors or anything, if there is, double check that your code matches mine. We're going to test out the armor reduction real quick. So let's see how we can get that going. Well, the first thing I want to do is open up the enemy stats, the starting stats, so it's a gameplay effect. And I'm going to open the full blueprint editor. It's just easier for me to understand what the hell is going on. So in the armor attribute section, we have it at 0, but let's add 20 armor. So now he has actual armor, but normally I don't think I would have the enemies actually have armor, but this is mainly just for testing. So now that he has 20 armor, we want to actually affect our armor using our ability. So if we open up the, I think it's in the weapons abilities section. So there's the player pistol ability, but we want the player pistol damage gameplay effect. And then again, I'll open the blueprint editor here. And so instead of health, I'm going to choose armor instead. And then I'm going to say that it's negative 10 damage. And then I'm going to open the retro character blueprint, and I'm just going to add a print string right here at the beginning of the take damage function. And then we're going to get the ability system component, and then we're going to get the float attribute. And we're going to do that twice. We're going to get both of them. So the first one will be health, and the next one will be armor. And then I'm going to do a append string node, and I'll add a couple more pins. And the first one here, I'm going to type in health with a colon and a space, and we're going to say that health is equal to this. And then in this C, I'll do a comma, space, armor, colon, space, and then I'll drag this value in. And once that is hooked up, I'm going to actually change the duration to be something much longer. I'm going to do 60 and then bring that back up. And now if I compile and save, we can test that out. And when I hit this guy first time, you can see it's 40 health and 10 armor. We had 20 armor to start with, so it did reduce his armor, and that's what we want. One more time. It looks like now it's 40 health and 0 armor. So if we hit him again, it should be 30 health, 0 armor. And it is. You can see in the top left there, now it's 20 and 0, or 10 and 0, and then one more will kill him. And he's dead. So our armor system is working, and now we can move forward. And I think what I'll do first is undo all of the things I did, with the exception of the print string. So I'm going to take the player damage here, and I'm going to change that back to negative 20, and I'm going to do health. And then in the pistol enemy starting stats, I'm going to have 0 armor. And I might even just remove this one here. So it's just health, and it's just 40 health. The next thing I'm going to do is a quick cleanup of something I did earlier, and that is changing the gameplay queue name. So in the gameplay queues, you can see this is called gameplay queue, player pistol damage, and instead I'm just going to rename it to take damage. And then up here in tools, I'm going to go to the gameplay queue editor. And I'm going to add a new tag. Instead of player pistol damage, I'm just going to say take damage. And I'll add that. And then I can close this for now. And in here, in the take damage, I'm just going to go over to this side here and change it from player pistol damage to take damage. And I'm going to compile and save. Next, I need to go over to the player pistol damage. And down here, it has the gameplay queue, player pistol damage. I'm going to remove that, and I'm instead going to use take damage. And now I can head over to the project settings, and we'll search for tags. And I'm going to get rid of the player pistol damage because I just want to use a standard gameplay queue for all damage. So over on the right side, I can just say delete, and there will be no issue because we are no longer using that old one. Another thing I want to do real quick, if you recall, when you kill the enemy, it continues to run its AI. So if you look on the top left, you'll see that it will do a ranged attack. Right there, it just did a ranged attack. It did another one, and we want to stop that when the enemy dies. So if we open up the enemy blueprint, right here before is dead, so we'll take all the stuff and move it over. All we want to do is get the controller. From that, we will cast to the retro FPS enemy AI. And then from this, we will get the brain component. And then we will run a function called stop logic. And once that has been stopped, we can continue on with all of the logic we made earlier. So now the character's AI will stop when it's dead. Next, let's get the enemy the ability to attack the player. So I think what I'll do is begin with creating an ability for the enemy that he can use that can do damage to the player. So I think this GA Retro FPS ability, I think I'm going to rename this to, instead of a Retro FPS ability, it's going to be specifically GA underscore bullet weapon ability. So with that selected, I think I can go ahead and create a child blueprint class that I'm going to call GA underscore enemy pistol ability. And then I'm going to create another blueprint class of the type gameplay effect. And I'll call this GE underscore enemy pistol damage. And so if I open the gameplay effect enemy pistol damage, there's only a couple things we need to do in here. And the first thing is going to be this modifier that's instant. So we'll add a single entry here, and the attribute will be armor, so that it affects the player's armor first. And we're going to have it stay with add. And we are adding, let's do -4. Let's say each one of these pistol shots hurts the player 4. And then the other thing we want to do in here is use that gameplay cue. And that would be right here under display, gameplay cues, and we'll just add 1. And we'll just make sure that that is take damage. And I think that's all we need to do in here, so you can compile, save, and close it. I'm going to close all of these other open windows because we don't need these for now. And then I'm going to open the enemy pistol ability. So I'm just going to add a couple functions in here. The first one's going to be called getLineTrace, and the next one will be called getEnemy. And for getEnemy, I'm just going to create a variable called pistol enemy. And it'll be of the type pistol enemy. And then I want to initially check and see if this is valid first. And then if it's not, I just assign this. So in order to assign the pistol enemy, you need to get the actor info. And this is available in all gameplay abilities. So I can split this return value, so it's a struct. And essentially, I'll add a return node. It will say if this is valid, we can return. But if it's not valid, we need to set this. But we actually want to first cast it. So instead of going directly to set, we're going to take this return value owner actor, cast to the pistol enemy, and then use that return value to set our pistol enemy variable. And once that's done, we just leave. So we got that done. We'll use that in a second. The next one, getLineTrace, is going to be pretty similar to the line trace in the player pistol ability. So you can open up the player pistol ability and go to the getLineTrace function, and we're just going to copy all of this, go back over to the enemy pistol ability, and we'll just paste that in there. So the first thing we do is we get this line trace, and then over here at the end, we have this return that returns an actor. I think that's what we want to do. Yeah, so everything's good except if you were to compile, you'll see a couple of red marks here. And what we want to do is replace this with the pistol enemy, but I don't know if the pistol enemy has an object pool. So let's go check out the pistol enemy and see if he does. All right, so we'll go ahead and add our object pool. And we'll just call that object pool dash bullet holes. And we'll set the pool size to 10. This should be fine. And make sure the subclass is the BP pistol bullet hole. All right, with that saved, we can head back over and we'll drag out the pistol enemy. And then from that, we'll get the object pool. And then we'll hook that up to the spawn pooled object. And we can delete the old ones. All right, now that that is done, I think just one more right here. And for this, instead of the camera, we're going to get that pistol enemy again. And we'll get the capsule component. We'll use that as our source. Now if you compile and save, everything should be working. I think what I'm going to do though is for this draw debug type on the line trace, I'm going to set it to persistent so we can see where the enemy shoots when he does shoot. And then I'll compile and save that. Next, I want to go to the event graph and we'll fill out some stuff here. We want to override fire weapon. So when you do that, it'll show this, and we can actually delete these. This will run without those being there. And then the first thing we want to do is get the enemy. So we'll run that function. Next, we'll get the line trace. And then we want to cast to the retro character. Retro FPS character we're casting to. And then we can take the pistol enemy. And from the pistol enemy, we will apply effect. And then the target actor is the retro FPS character. And that should do everything we need in here, except for I think there's some class defaults we need to set up. And what we want to do is, for the weapon effect, we're going to choose the enemy pistol damage. Weapon range, we'll choose 5,000 for now. And then for the ability tags, we want to add one. So up here in the add new gameplay tag, we'll do a drop down there, and we'll just say enemy.ranged attack. And we'll add that. And that's what we want to fire. And then down here in the activation blocked tags, we actually want the pistol cooldown. But it does say player.pistol cooldown, but it'll be fine, it'll still work. And then down here in the cooldowns, we'll just select our pistol cooldown. And what that's going to do is allow the enemy to pause momentarily before firing his weapon. Otherwise, he could fire multiple times really quick, and we don't want that. So I think that's going to be all we need for this currently. So we'll compile and save that. And then we'll head over to the actual enemy, the pistol enemy itself. And in here, we want to show that the enemy is shooting. And so a good way to do that is to add a point light. And that should flash whenever he shoots. And we'll just leave it called point light. And then on these, we can delete these. We don't really need those. But we want the ranged attack, if we can override that. So we'll override the ranged attack. And if you remember, in the enemy, the ranged attack was just printing a string. So we can delete the print string here because it's not going to fire anyway. And then back in the pistol enemy, we can fill out what happens when the enemy shoots. So the first thing we want to do is actually activate its ability. So let's grab that ability system component. And from that, we'll do a try activate abilities by tag. And then the gameplay tag container we can promote to a variable. And we'll turn off remote activation. And then for the gameplay tag container, if you compile and save, you'll see now the default value is available. And we're going to choose enemy ranged attack. And that matches the tag we have on the ability. Next, we're going to take that point light and we're going to set hidden in game. And we're going to say false, it's not hidden. And then we'll just do a quick delay. 0.2 seconds will work fine. And then we'll get this point light again and then hide it. So make sure that that new hidden is set to true. And so the point light itself, we should set the stats on this. And if we switch the viewport, we can kind of see where it is. And we'll say the location on the X is at 16, so it's out in front of the character a little bit. And the intensity, we'll say, is 1900, somewhere in there. The attenuation radius will be 800. And then we're going to set hidden in game as default so that it only flashes when the enemy shoots. Now, I think the other thing we need to make sure is set is the default abilities. So under Retro FPS, there's default abilities and there's 0 array elements, but we need to give him his abilities. So select the GA_enemy pistol ability, and now he should actually shoot. And then I think the only other thing to do to make sure that he's going to cause the player damage is to set the capsule component on the player, FPS player. It needs to be set from pawn, the collision preset from pawn, to something like block all dynamic, because visibility needs to say that that's blocking. You can compile and save, and then we can test it out and see if this works. And remember, on the retro character, we have this print string, which should show the player's health and armor. So I'm going to get out here and have him shoot me. He missed me. All right, now I have 96 health and 0 armor, 92 health and 0 armor. So he is shooting me. It is going down by 4 points. But let's go ahead and give myself some armor. So in the starting, let's see, where is that? That would probably be in the player. Yeah, starting stats, GE starting stats. We'll give ourselves 20 armor and then compile and save. And watch this guy shoot me. All right, he missed. All right, now I'm at 16 armor, 100 health. 100 health, 12 armor. Everything is working perfectly. And what's cool about how his AI is developed is that if you keep moving, he's not going to hit you, which helps with avoiding damage. Awesome. So that's going to do it for this video. This is only the first part of the health and armor section of the Retro FPS tutorial series. Up next, we will be doing a UI so that we can see the character's health and armor and how it's affected when enemies shoot us. So thank you for watching. Please like, please subscribe, and I'll see you in the next one.